When you have a circle and you have a section of the circle shaded, or you have a sector that's set apart, or you have just an angle, a central angle in the circle, it's usually mentioned that some letter, in this case O, is the center of the circle. So in this case, X represents my central angle of that sector, that shaded sector. When you have a sector that's shaded, or you have a sector that's at least highlighted or set apart, or you have an angle that's mentioned here, X is the central angle of this sector that's shaded. Okay, that sector is a section or a portion of the whole circle. In other words, the area of that sector is a portion of the total area of the circle. Likewise, the angle that makes that sector, or the central angle of that sector, is a portion of the number of angles all the way around, the number of degrees all the way around, and the number of radians all the way around. If it's in degrees, it's a portion of 360. If it's in radians, it's a portion of 2 pi radians. Here's what I really want you to know. Those proportions are equal. So we have the proportion of the arc AB. So arc AB here, it's a portion of the circumference, portion of the circle's circumference. The shaded region, the area, is a portion of the area of the entire circle. Angle AB, AOB, right, in this case, this angle X is a portion of either 360 if it's in degrees, or 2 pi if it's in radians, whatever that angle is. And you'll know if it's in radians or degrees based on the notation of the question. Those proportions are all the same. So if this is, let's say, 1/3, let's say if this is 1/3 of the circle, angle X is 1/3 of 360, or 1/3 of 2 pi. Those proportions are equal. Here's where it really helps on various problems. Here's a sample problem. This sample problem is like one you might see on the SAT or in a school assignment or ACT. Point C is the center of the circle above, and we have a shaded region. What fraction of the area of the circle is the area of the shaded region? Well, we can see that the central angle of the shaded region of that sector is 100 degrees. So we know that 100 degrees is some portion of all the degrees going around. So 100 degrees compared with 360 degrees, that's the fraction we're looking for, because all these fractions are the same. So they're looking for what fraction of the area of the circle, which is this proportion here, right? But they give us degrees, which we know the degrees of that central angle is the same proportion in relation to 360. But we don't even have to find the area of the circle. We don't have to find the area of the sector. We can't anyway because we don't have the radius of the circle. But all we have to do is reduce this fraction. I know that 10 goes into both, so I can cross out the zeros. 10 and 36, I know that 2 goes into both of those numbers. 2 goes into 10 5 times. 2 goes into 36 18 times. That is actually my answer, 5/18. 5/18 of the circle is shaded. 100 is 5/18 of 360 degrees. Here's another problem that we had come up with. If the radius is 5 centimeters, what is the minor arc length of the shaded sector? So if the radius is 5 centimeters, what is the minor arc length? So minor arc length means the small arc length here of the shaded section here. Okay, so we're looking for that arc length. Well, we know that based on these proportions up here, arc length is a portion of the circumference. If we are given that the radius is 5 centimeters in this case, the radius helps us get the circumference. And hopefully you know that circumference is 2 pi times the radius, right? We're talking about minor arc length, which is this arc length here, in relation to the circumference of the circle. We know that the relationship between this angle and the 360 degrees of the entire circle, we know that that is 5/18. We've already figured that out. And we know that that proportion is the same for the arc length. So arc length, I'm going to call it x here, in relation to the circumference, which is 2 pi r, well, 2 pi times 5 in this case, so 10 pi. Now, you could cross multiply and say 18x is equal to 5 times 10 pi, but really all you need to do here is multiply both sides by 10 pi, right? Because that will get rid of it from this side. 10 pi divided by 10 pi is 1, so it goes away when I multiply by x. And then I just have 10 pi times 5, which is 50 pi over 18. 50 pi over 18. I can reduce that fraction by, let's say, 2 and say 25 pi over 9. There's nothing else I can do with this if I want an exact answer. So this would be on a multiple choice question. Or if they could say, which answer choice below is the closest to it, and it could be a number that if you type this into your calculator, you get a decimal answer that matches that.